On Earth, salt water covers an area of about 360 million square kilometers. The oceans make up approximately 71% of the surface and 90% of the living space. The total volume of the oceans is around 1.35 billion cubic kilometers, with an average depth of nearly 3,700 meters. Normally, a person drinks about 2 liters of water per day, which adds up to 730 liters per year. So, with the amount of water in the oceans, if all 7 billion people on Earth went to the beaches to drink water at a normal pace, without using the toilet and without developing any kidney-related diseases, it wouldn't take all that long. In just about 264 million years, humans would drink up all the water in the Earth's oceans. Back in Earth's early days, when volcanoes were still highly active and releasing various gases, the atmosphere began to form with a composition very different from today's atmosphere. At that time, the atmosphere contained very little free oxygen, with most of it being carbon dioxide and water vapor. As Earth cooled down, water vapor began to condense and fall to the surface, accumulating over time and forming the first oceans. Mathematicians believe that since their formation billions of years ago, the oceans have undergone major changes such as changes in salinity, sea level, the formation of massive ice blocks, the shape of the ocean floor, and especially the distribution of ocean and land that resulted in today's continents and oceans. There have been many theories about this formation, including continental drift, seafloor spreading, and plate tectonics. In fact, humans know more about the Moon and Mars than we do about the oceans on our own blue planet. Exploring the ocean depths remains extremely difficult, partly due to current technological limitations and partly because governments invest little in oceanographic research, as it does not yet bring immediate benefits. The ocean is divided into several zones. Epipelagic zone, sunlight zone from 0 to 200 meters deep. Mesopelagic zone, twilight zone between 700 and 1,000 meters deep. Bathypelagic zone, midnight zone from 1,000 to 4,000 meters deep. In this region, you may find great white sharks, a species that inspires awe, especially among women, since they swim constantly without ever losing weight. In the dim twilight of the deep sea, these sharks either chase prey or camouflage themselves, in areas where light barely reaches. The great white may not see you clearly, but it will definitely catch you. Abyssopelagic zone, down to around 6,000 meters deep. Hadal-pelagic zone, the trenches between 6,000 and 10,000 meters, the deepest part of the ocean. As we know, the oceans on Earth today, ranked by area from largest to smallest, are Pacific Ocean, Atlantic Ocean, Indian Ocean, Southern Ocean, and Arctic Ocean. A major 10-month expedition, from December 2018 to September 2019, was conducted to reach the deepest points of each of these oceans. The journey spanned 47,000 nautical miles, about 87,000 kilometers, completing 39 dives using the submersible limiting factor, the only submarine in the world capable of diving to 11,000 meters deep. This submarine was equipped with the latest multi-beam sonar technology, a system that uses sound waves to map the seafloor. The device emits a series of sound pulses to map portions of the ocean floor. The team stated that this expedition allowed them to accurately map some of the most remote and deepest places on Earth, while confirming the depths using measurements collected from both the sub and a support ship. Approximately 61% of the places they visited had never been mapped using modern technology. The deepest point in the Arctic Ocean lies in the Malloy Deep, with a depth of 5,551 meters. A NASA scientist captured images of mysterious holes that had appeared on the ice surface in a marginal sea area of the Arctic Ocean, near the coast of Canada. These holes looked as if something hot and sharp had pierced through the ice, leaving melted edges around the holes. Clearly, these were not man-made, as the area is uninhabited, and the ice is too thin for vehicles to travel on. If this were a natural phenomenon, no scientist had ever seen it before, either in real life or in any documented records. Scientists from the U.S. National Snow and Ice Data Center believe that the holes in the surrounding rings were caused by warm water appearing on the ice and then draining below, though where that warm water came from remains a mystery. Some scientists believe the holes might be linked to warm ocean currents passing through the Arctic Ocean, or possibly a stream of warm underground water from inland somehow reaching the icy ocean surface. Meanwhile, in the Southern Ocean, the deepest point is the Factory Deep, located in the Sandwich Trench, with a depth of 7,432 meters. In 2007, a Japanese scientist shared a story about a monster he discovered deep in the ocean near Antarctica. It was white, had the body of a fish, but with two arms resembling those of a human. Although he only had a brief moment to observe it, he later brought the story up for discussion with other scientists. Of course, everyone initially dismissed it as a ridiculous tale. But everything changed when they saw a photo capturing a mysterious sea creature, one that no one could explain. Over the years, rumors began to spread about an unknown monster hiding in the icy waters of Antarctica. The Japanese named it Ningen, modeled after a human-shaped creature from national folklore. Interestingly, the shape of the Ningen strongly resembled a human. It had two arms with 5 fingers, large eyes, and a slit-like mouth. However, no one could identify its species. Scientists proposed a few theories regarding this mysterious creature. The most prominent theory is that the Ningen is a giant stingray that occasionally surfaces, sparking imaginations. Another theory suggests it might have camouflaged itself among icebergs, leading to the Japanese scientists' misidentification. There's also a theory that the Ningen might actually exist, but is a mutated individual. This theory goes further, explaining that in nature, there are many strange and deformed creatures, and not every animal can be clearly classified by humans. The deepest point in the Indian Ocean is measured at 7,455 meters, located in the Java Trench just off the coast of Indonesia. In 2004, an earthquake with its epicenter in the Java Trench released so much energy that it actually altered the Earth's rotation, shortening the length of a day by 2.68 microseconds. The Atlantic Ocean, the second largest of the 5 oceans, has its deepest point in the Brownson Deep, part of the Puerto Rico Trench, reaching 8,605 meters in depth. During the 1970s, the Puerto Rico Trench became a major dumping ground for medical waste. In just 5 years, more than 387 tons of waste drifted into this area, the equivalent weight of over 2,000 Boeing 747 aircraft. Even the ill-fated Apollo 13 spacecraft, after its explosion, along with its nuclear generator, eventually sank into this trench, creating radiation pollution over a wide section of the seabed that could last for thousands of years. According to data, the deepest point in the Pacific Ocean and the world is the Challenger Deep, located in the Mariana Trench, with a depth of 11.34 kilometers. The Mariana Trench lies on the ocean floor of the northwestern Pacific Ocean, east of the Mariana Islands, stretching all the way toward Japan. It is approximately 2,550 kilometers long and has an average width of about 69 kilometers. This makes the Mariana Trench the deepest part of Earth. To visualize, if we placed Mount Everest, the tallest mountain in the world, into the trench, there would still be 2 kilometers of water above its summit. Nutrition experts believe that animals living at such extreme depths of the ocean must be herbivores, as carnivorous behavior would be difficult to sustain. According to many researchers, the Mariana Trench is so massive it could contain all of the waste humans produce for thousands of years. Currently, humans generate around 2 billion tons of waste per year, and this number is expected to increase to 3.5 billion tons by 2030. This raises an interesting question. Instead of relying on landfills or incineration plants, why don't we use the deepest trench on Earth as a global waste disposal site? Today, scientists can survey the ocean floor more effectively and efficiently than ever before, thanks to advanced technologies such as sonar waves, unmanned underwater vehicles, modern robots. With these technologies, humans can finally see the ocean floor and may soon leave behind the age of oceanic blindness. The push to explore Earth's final frontier could yield immense scientific benefits, from expanding our understanding of marine biodiversity to tracking climate patterns. If you found this video helpful,